Hi, in this video we are going to solve a combined probability question in past paper 3H May 18. We are going to solve the question using tree diagram to simplify the representation of the sequence of the events visually, and also to show you how the tree diagrams work. Okay, let's see question 20 in the past paper. There are 9 counters in a bag. There is a number on each counter. As you see, we have 3 counters labeled with number 2 and 6 counters labeled with number 5. Leave takes at random 3 counters from the bag. He adds together the number on his 3 counters to get his total. Calculate the probability that his total is an odd number. This means that if our friend takes the 3 counters, and for instance, if the first one labeled with number 2, and if the second one labeled with number 5, and if the third one labeled with number 2, and we add up all these labels, it will be 2 plus 5 plus 2 is 9, which is odd number. But if he takes 3 counters with labels 2 and 2 and 2, for instance, the sum will be 6, an even number. Now the question needs all the possibilities that the sum of the labels for the 3 counters should be an odd number. We know that the probability of something or event happening is the amount of successes over the amount of possibilities or the total number of outcomes. You should understand this formula when you solve any probability question. Now let's draw our tree diagram. We have 3 counters labeled with number 2 and 6 counters labeled with number 5. The question clearly saying that 3 counters have been taken at the same time, but we will treat that as one counter taken after the other without replacement, and we'll see how this will affect the probabilities for each selection. So during the first selection, either counter label 2 is selected or 5 is selected. Now for the second trial, if we select 2 in the first trial, so in the second one it could be 2 or it could be 5. Then if we select 5 in the first trial, so in the second trial again it could be 2 or it could be 5. Now for the third trial or selection, if it is 2 in the first and 2 in the second, the third will be either 2 or 5. Or if it is 2 in the first, 5 in the second, the third also will be either 2 or 5. If it is 5 in the first and 2 in the second, the third will be either 2 or 5. And finally, if it is 5 in the first and 5 in the second, the third also will be either 2 or 5. So these are all the outcomes or possibilities we have. Now, if we go in this direction, the first outcome will be 2 and 2 and 2. Or if we go in this direction, the second outcome will be 2 and 2 and then 5. Or if we go in that direction, it could be 2 first and then 5 and then 2. Next one is going to be 2 and then 5 and then 5. The fifth direction is going to be 5 in the first and then 2 and then 2 in the last. While this direction will be 5 and 2 and 5, then we have 5 and 5 and 2. Finally, 5 and then 5 and then 5. So we have 8 different outcomes. Now we are going to put down the probability values in each branch. Now since we have 3 counters labeled 2 and 9 counters in total, so the probability of selecting counter labeled 2 in the first trial is 3 out of 9. And then the probability of 5 is 6 out of 9 for the similar reason. Just note that the sum of these 2 probabilities for this set of branches is 1. Since we mentioned earlier the selection is without replacement, which means that when our friend leave selects the first counter, he doesn't put it back in his bag before selecting the second counter. Now let's see the probability of selecting 2 in the second trial. So how many counters labeled 2 are left in the second trial if he already takes counter labeled 2 out? That's 2 counters. But how many counters are left in total? That's 8. Why? Because we have 2 counters left labeled 2 and still we have 6 counters labeled 5. So the probability of this branch will be 2 over 8. Okay, now what about the counter labeled 5 in this branch? Still 6 counters left and 8 counters in total. So P of 5 or probability of 5 will be 6 out of 8. Again, check that those two probabilities add up to 1. Now let's look at the other side. What is the probability of selecting this particular counter 2 here after we got 5 in the first trial? We have 3 counters labeled 2 and 8 in total. So it's just 3 out of 8. Now the probability of selecting counter labeled 5 in the second trial after selecting 5 in the first one, it will be 5 out of 8. Now for this branch, let's see how the probabilities will be in the third trial. If he selects 2 in the third trial after selecting 2 in the first one and 2 in the second trial, only one counter labeled 2 left and 7 in total. So the probability will be 1 out of 7. Now what about the counter labeled 5 in this branch? Still 6 counters left and 7 counters in total. So the probability will be 6 out of 7. Now for this branch, we have counter labeled 2 out in the first trial and counter labeled 5 out in the second trial and 2 in the third one. So the total counters is 7 and the probability for this branch is 2 out of 7. Now for this branch, the probability will be 5 out of 7. Again, check that those two probabilities do add up to 1. Now the fifth and the sixth branches have the same probabilities as the third and fourth one for the similar reasons. 2 out of 7 and 5 out of 7. Here in this branch, we have counter labeled 5 out in the first trial and counter labeled 5 out in the second trial and 2 in the third one. So the total counters is 7 and the probability for this branch is 3 out of 7. Finally, this branch, the probability will be 4 out of 7. And now we can answer the question. First, we need to see which selection branch gives a total odd number. Now we have to sum the labels on the counters to see whom are even and whom are odd. Let's see the branches here. The total of the first branch is an even number. Why? Because if the first selection is 2 and the second 2 and the third also 2, so the total will be 6, which is an even number. While the total in the second branch is an odd number because the total is 9. So this will be the first selection, P of 2 and 5 and P of 2 and 2 and 5. For the third branch is 2 plus 5 plus 2 is also 9, which is an odd number. So the second selection is P of 2 and 5 and 2. This branch is 2 plus 5 plus 5 is an even number, which is 12. And this branch is 5 plus 2 plus 2 is an odd number. So this will be our third selection. The sixth branch is an even, and this branch as well is an even number. While the last one is 5 plus 5 plus 5 is 15, so this will be our last selection, P of 5 and 5 and 5. So P of the total of the three counters are odd number is P of 2 and 2 and 5, or P of 2 and 5 and 2, or P of 5 and 2 and 2, or P of 5 and 5 and 5. We know that AND is always times, while OR is always plus. So from the diagram, we have the probabilities. So 3 out of 9 times 2 out of 8 times 6 out of 7 plus 3 out of 9 times 6 out of 8 times 2 out of 7 plus 6 out of 9 times 3 out of 8 times 2 out of 7 plus 6 out of 9 times 5 out of 8 times 4 out of 7. This will be equal to 36 out of 504 plus 36 over or out of 504 plus 36 again over 504 plus 120 over 504. This will be equal to 228 out of 504. And that is that.